We should be live. We can wait a few more minutes and wait if someone is joining. In the meantime, open MATLAB. Okay, 1 minute and we start. Okay, I think we can start. In any case, the seminar will be recorded, so you can you don't have to run away, but you can view this seminar another day. Okay, the main purpose of this seminar is to introduce you the basic concept of image processing. This seminar is the first seminar of a series. In the next weeks, probably, we are going to go into details of what we are going to see today. Today we will see the basic importing of images, and we are going to see how images are described in MATLAB. If you have questions, you can ask whenever you want in the chat. I will try to keep an eye on the chat, and I think we can start. One last thing. Today's seminar will last about 30 minutes or 45 minutes. Okay. The very first thing that I want to show you is how to import images. If you want to import an image, of course you have to save that image on your disk, the disk of your computer, and then you can import that image using the MATLAB function imread. Using imread, in this case, we are going to read a picture that is called fruit. We are assigning this image to a variable I. Here I can run the code, and as you can see in the workspace where we store our variables, we have our image. Images are represented as matrices. It is important to notice that the first two dimensions are the two dimensions of the image, while the third dimension is referring to the number of channels, of color channels, and this because images are composed of three different matrices, each one for one different color. In particular, the three colors that are described with these three matrices are the red, green, and blue channels, and we are going to see how the composition of these three colors gives us the wide color spectrum of the images. Another interesting thing that I want to tell you now is that now we are working with images that are described with 8 bits. Using 8 bits, we are able to describe colors that have 256 levels of colors of intensity. If you increase the bit depth of the color, you are going to have a much wider color space. But traditionally, we work with 8-bit images because 8-bit is enough to reproduce the majority of the colors that are interesting for us. Okay, first thing is to import the image. Then, of course, we may want to show and to see the image. So we just type imshow. With imshow, it is okay. We can see our image. In this case, we have some fruits. Similarly, we can import other images, but this time we have to assign the new image to another variable, in this case I2. Same thing, we import the image airplane, and this is our airplane. If we want to show together two images, we can use the function imShowPair that will need as argument to the two images. Then we can use the parameter, the argument Montage, in order to have a plot that show the two images together. These are the most simple functions when you work with images, the import and the plot of images. But now we can go to the next step, and I want to talk about what we said before. We've seen that images, colored images, are composed of three layers, three matrices, each one representing one different color. These colors are red, green, and blue, and this is exactly the way common digital sensors that we can find in our mobile phone or in our digital cameras are built. So a digital sensor has pixels that are sensible to one specific color. We have pixels that are sensible for red, for green, and blue. When we read the intensity of these colors, we are able to generate, let's say, three different images, each one representing one color. When we sum all together these three channels, we obtain the full spectrum. I think that these images are a very simple way for understand this concept. If we sum these three colored layers, we obtain this very natural image. And the same concept is exploited by our screens that have red, green, and blue light emitters that are turned on with different intensity in order to reproduce images on our screens. And that's it for the introduction. We may want to understand and to do some computation on these three colored channels. So we are going to see how we can do this. Again, we can import an image, in this case an example of three different disks, red, green, and blue. If we want to know the size of the image, we can use the function size. We have 512 since it is squared, and then again three channels, and this means that we are working with a colored image. But another way of checking the dimension of our image is to go to the workspace, and here you see again the dimension of the image we just imported. Okay, now we can try to look at these three layers. If we want to plot, for example, the red channel, we are going to see exactly this. We have an intensity representation of the red channel. What does this mean? That the black areas are pixels that don't contain any red value, while the very bright side of the image is the portion of the pixels that contain a red color. In this case, I extracted the red channel by accessing the first layer. If I try with the second layer of our image I, we are going to extract the green layer. Here you see that the green the green ball is represented as a bright circle. But you may notice that there is a bit of green also in this blue circle. This means that this blue is not only blue but also contain a bit of green. Same thing can be done for the other channel. If we want to see where is the blue in our image, we access to the third dimension of our image, the third layer, and we have the blue. Very simple. Another interesting thing is that we can try to read our image, and we can read the maximum value or the minimum value of a color channel. For this, we can again extract the red channel of the image, and using a very simple max or min function, we can see that the pixel with the highest value has value 254. The maximum achievable is 255. And similarly, for the minimum value, we have 0. 0 means that we don't have any red color, and I guess that pixels with value 0 are in the dark area of the image. Sure, you can do this analysis by extracting the channels manually in this way, but MATLAB offers a very nice function for this. If you use imsplit, you have to pass the image, and you have the 3 different channels. Similarly, we are going to have the same result as before, but with just one function. In this case, I used Montage. It's another function that allows you to plot different images. In this case, we have 3 images, so the 4th place will be empty. This dark is because we are not showing an image here. But I think that it could work also like this, exactly. If I pass another argument that is the original image, we are able to see the 3 channels, blue, blue, red, and green, and our original image. At this point, it is very important to start talking about grayscale images, and this is because grayscale images are very useful for us, that if you want to work with computer vision, why should you convert image to grayscale? Because grayscale images are images that are represented with just one channel. You are now working with 1/3 of the original space that is required for RGB images, and you are still maintaining the objects, the meaning of the image. So if you really don't need a specific application with the colors, I suggest you to work with grayscale images. And we're going to see how easy it is to handle these images. Here I can again read another image. It's the same we have seen before, our airplane, and we can convert our image to a grayscale image. This is automatically done by a function that is called im2gray. We have just to pass the original image. So here we can see the conversion. I want to see with you the original matrix. Our black and white image is now called B&W. If I look at B&W, I see that the dimension of the image is exactly the same, 256, but here we no longer have three layers, three color channels, but we just have one layer. So this is exactly a matrix. Okay, this is interesting, and again, all our pixels will have a value that is in the range between 0 and 255, for a total of 256 values. Okay, this allows us to reduce the computations since we are again working with just 1/3 of the original space. Okay. Similarly, we can use again the size function to get the size of the image. This is very trivial. Interesting thing, if you want to analyze or to inspect an image, you can use an application that MATLAB provide with the computer vision toolbox, if I'm not wrong. This app is called Image Viewer. Here you have to go to the Apps tab. You can open this. Here you have all the applications depending on the toolbox that you installed. Here in the favorites, I already pinned our Image Viewer app, but you can find it again here in the Image Processing and Computer Vision toolbox. Okay, let's see. Image Viewer. Here we can open an image. I think we can use again the airplane. Okay. I hope it is understandable. We can zoom in the image. Okay. At this point, we can use this interesting instrument. It is called, I don't remember inspect pixel values, and with this cursor you can inspect the single value of each pixel. It's a bit slow since I'm streaming the seminar, but I promise that it's much faster. Okay, so as you can see, I move in the cursor. I can see the values for the R, G, and B channels of the image, and it's trivial. In the blue region of the image, you will see an higher value of blue. Similarly, we can, of course, you can increase the size of your inspector tool. You will have a larger grid. Probably I did something wrong. Anyway, I think that it is clear to you. Okay, now it's slowing down a bit. Just one thing, if we go to the black area, you will see that all the three channels have a really small value of intensity, and this is understandable. Okay, I think that this is pretty clear. At this point, I want to talk about the contrast, since it is a very important aspect when you work with images. For this part of the seminar, I selected an image of a city taken from the satellite. At this point, you may see that the image is a bit faded. It's lacking a bit of contrast, so you may want to increase the contrast. But before adjusting the contrast, I want to show you another function that allows us to evaluate the contrast of our image. By using the function imhist, we are able to plot an histogram, and this is the histogram of our image. The histogram is a sort of map that is showing us where the pixel of a given intensity, how many are the pixels with a given intensity. So if you see this image, you are able to tell that basically all the pixels are in a specific region of our scale. And this is not something good, since we could be able to describe this image with all our values, but we are just using a subpart of our levels. So the basic idea is to stretch this curve on the entire range of levels that we can plot. This is possible by using a function that is called imadjust, and I want to show you how it works. Okay, and here you can see that the image now has deeper blacks, but also the whites are now brighter. And this is because we have somehow stretched automatically the histogram of our image. Just to be sure, we can plot again our histogram. It's exactly this one. We have now pixels with value 250 and pixel with value 0. This means that we have somehow increased the dynamic range of our image before and after. This is very useful when you have to somehow fix the exposure of your image. Okay. We have seen that this automatic contrast adjustment is working on grayscale images, but if you are working with colored images, you may want to do the same thing. Unfortunately, you can't use the same function ImageAdjust since it works only with black and white images. If you, for example, try ImageAdjust, you will get an error. Okay, since ImageAdjust is only supported for 2D grayscale images. We can do a similar thing using another function that is called imLocalBrighten, and the result is very similar. In this case, we are going to use an underexposed image of a train, and as you can see, I hope it's clear. As you can see now, you are somehow recovering the contrast in the image. All these parts that before were underexposed are now a bit brightened, still keeping the parts that before were good for us. Okay, very stupid thing, but it's interesting to have these functions. Okay, at this point we can talk about intensity thresholding. We have seen that images are described with pixels, and each pixel has a different intensity. Intensity is described with a number between 0 and 255 in the case of 8-bit images. We can play a bit with these intensity values, and here I want to show you a very funny image. We have Leonardo DiCaprio and a green background. Now, if we know that the background is described as green pixels, we can use a threshold on the green channel in order to segment the silhouette of Leonardo DiCaprio. This strategy is used very often in the film industry, but also by YouTubers, since by using a green background, you are able to segment the person that is talking in a very easy way. There is one assumption that you have to do. You do have to have green only on the background, in the background. If you're wearing a green t-shirt, this is not going to work. Okay, so at this point we can work on the green channel. So we will take the second layer of our image, and we are going to extract all the values under a threshold. The threshold is is selected here, we can decide a value from 0 to 255. As you can see, if I move the slider, I'm able to select a different portion of the image. I think that probably this threshold is enough. Okay. Here our mask is extracting all the values that are below this threshold. We have now declared mask. What is a mask? Is a logical matrix composed of zeros and ones. We have zeros in the black area and ones the white area. Now that we have this mask, we are able to segment the image. We can use the mask for a multiplication. We can multiply this mask by the original image. So the pixel that will be multiplied by 1 will be the same, while all the pixels, all the other pixels that are multiplied by 0 will be 0. So we are setting all the background to 0, but we can do similar things and change the color of the background in the way we prefer. Here you have a bit of green, and this means that this part of the image is not exactly green, as the same way of the same color of the background. I can try to play a bit with the threshold, but I think that we should work. Okay, again, now we are changing the threshold, but there are other parts that of Leonardo that now have been set to 0. So it's a bit hard to find the exact threshold. I think that we can stay here all the day long, but I hope the concept is clear. Okay, and this is how to segment an image using colors. The same thing again can be done for black and white images. We can import our airplane image. We can plot again the histogram of this image, and as you can see here, a large number of pixels is dark. It's not exactly deep dark, it's not 0, it's 50, but it's dark. Why? Well, because in this image we have the sky that, when is converted to black and white, is converted to a dark color. At this point, by knowing this, we can say, okay, we take all the other pixels, excluding the dark pixels that describe the sky. And this is exactly what we can do. By setting a threshold, I can say threshold could be 60, 70. Let's see. Okay, by using this threshold, we are able to segment the shape of the plane. In this case, we are more precisely, we are defining a mask with all the colors under this threshold, but the same thing can be done in this way. Don't find the key. You will invert the colors exactly like this. You will have one for all the values that are over a threshold. And I think that this is working, but it's not perfect. It's not perfect. Why? Because we have these clouds that are white, and also our airplane is white, so it's not easy to segment the our airplane just by using the intensity of the colors in the image. But I think that we are still getting a good result. At this point, I want to talk about the application that MATLAB is giving us. We've seen how to threshold a value, an image, using the level of intensity of the pixels, and we did this manually, but you can do the same thing in a very intuitive way. Again, you have to go to apps, you go to color thresholder. Okay. I think it's loading. Yeah, it's loading. I can see a window. Why? Thresholder. Okay. The fact that I'm streaming the seminar is slowing down everything. Usually MATLAB is not super fast, but it's usable. At this point, we can load our file from image or from workspace. Last time I load the image from file, but this time I want to show you this alternative. We can take this image. It's still loading something. I don't know what. Can try to quit the browser. Okay, and it's still loading something. Anyway, I can talk. Using this app, you're able to visualize all the colors that are inside your image using different color representations. Today, we don't have time to talk about all the different colors representation, because it could take a lot of time, but no, it's still loading. But what I want to say is that using different representation, you are able to segment the colors in your image. Each representation is different from the others, and at this point you may want to select the best representation of for your colors, and but I can't continue without the application. I think I'm going to quit. Okay, just a second. Color the shoulder. Yeah, color the shoulder is an app that is not super light, so it requires some computations, as you have seen. Okay, we load an image. Let's try another image. You can select this pepperoni. Wait a few seconds. Okay, different color representation, as I was saying, can lead to different results. You have to, I suggest you to select the color representation that best divide the colors you are interested in. At this point, we can select the RGB or HSV, but also the other two are fine. I'm a bit sad that it's taken such a long time. Because this is probably the most interesting part of our seminar. This is something that is very useful, but because it is very fast to be used. Not today. Okay, we can try later. I don't know why. It's a bit embarrassing, but I think we can do it. One last try. This is a very useful tool that I want to show you. I have to insist. Color the shoulder. I close the script. Nose. Color the shoulder. Load the image. Load the image from file. Our pepperoni. Okay, as I was saying, we can select one of these color spaces. It's the same. Let's take HSV. At this point, okay, it's working. Wow. At this point, we are working with HSV. I prepared a small image in order to show you how this representation works, and it's here. Basically, you can describe colors as 3 different channels: red, green, and blue. This is the RGB representation, but you can also use the HSV. Here you have 3 values: one for the hue, so I would say the color, one for the saturation, and one for the value. Okay. Okay. Here you can see the saturation and the value. When you want to segment an image, you can for sure try to use these sliders and try to select by playing a bit with these 3 values. For example, I want to use to segment the green part of the image. Okay, now in this cone I selected the green, more or less. Then I have to play with the saturation. Okay, and then with the value. Now I think that this is satisfying. We have segmented the green part of the image. We can also have a binary mask, so we have 1 for the green area and 0 for the remaining part. You can invert the mask, so now you are selecting the remaining part, and that's it. But there is another tool that is very interesting. I reset the threshold, we start. As you saw before, when you segment the image, this representation shows you what you are selecting, and you can also use this instrument, this Polygon Drawer, and you can draw a polygon around the area that you want to segment. This is much more intuitive than playing with these sliders. Okay. Okay, you can rotate this manifold the way you prefer, and I think it is clear. For sure, this graphical method is very effective and fast. Now I'm selecting also the yellow, but you can adjust your polygon and you can play. It's very funny. I have to make this. Okay. And that's it for this part. I was okay. Last point of this application is the export button. You can export the images once you have segmented it, but you can also export the function. If you export the function, you get a function that does exactly what you did before. You just have to pass an image. In this case, the argument is an image called RGB, and you are going to get the binary mask and the segmented image. Very simple. In a few seconds, you have your image. your segmentation algorithm. Okay, I think that we are running out of time. One last thing, we are almost done. Automatic thresholding. It's another way of segmenting the segmenting images. If you assume that your background is darker than your darker than your object, the object that you want to segment, you can use automatic thresholding. You can use, in particular, a function that is called imbinarize, and automatically this function is able to extract the shape of the object that is in front of the dark background. If you are working with a white background, you can do a very similar thing. You have to pass another argument that tells the function that you are not working with a dark background but with a white background. Okay, you can use a more refined algorithm by adding the adaptive argument. This way, that the threshold is not more computed on the entire image, but is locally evaluated. So this means that you are not going to have one threshold for all the image, but you are going to have different threshold for every region of the image. And in theory, this should improve your segmentation. We can try it. As I said, I added the adaptive argument to the imbinarize function, and this is the result. I think that it's a bit better than the imbinarize alone, but it's personal. You can tune a lot these kind of functions. If we want to show you these images, okay, as you can see, if you use the adapt, you have a more fine, a more precise segmentation, but we are also extracting the clouds that were in the background, and this is not something very good for us, but this is the limitation when you work on the pixel values. This is why nowadays we work with machine learning algorithms that are smarter than these kind of traditional solutions, but they can be very effective for simple use cases. One last thing, and probably this allows to introduce what we are going to see in the next seminars, that for sure will be more advanced than this. It is possible to use these algorithms for more interesting tasks like cell segmentations. And here I'm showing you the example that I made before. Again, I'm using the imbinarize function, but this time with by saying that the background is bright and not dark, and In this way, you are able to segment the shapes of the cells in the image. Next time, we're going to see how to improve segmentations like this. I think probably next week we are going to have a second seminar, but please follow us on our socials, and I will keep you updated on the next seminars. I think that for today this is all, and I think that in the chat there are no questions, so good, fine, and see you next time. Thank you, everyone.